A new study finds that critical ocean current has not declined in the last 60 years. Hello friends, Jim here, and this is via courtesy of Woods Hole Oceanographic Institution, or WHOI. And it's a lovely photograph of a CTD rosette, which can measure ocean's conductivity, temperature, and depth, as well as collecting water samples at varying depths, hence all the slew of different CTT devices, as well as having basically Nansen bottles on there where you can collect a sample at a specified depth. And in my All About Salinity video, I discuss how by measuring the conductivity in the oceans, you can then calculate the salinity, and then together with the temperature, calculate the density as you take vertical profiles of the water column. So AMOC, as we know, helps regulate Earth's climate and weather. Right? 71% of Earth is water covered. Right? Planet should be called Oceanus. And the oceans are the drivers of climate. Let's just state it. You've heard me say that many times. So what the ocean does in its movements, so on. In the Atlantic Ocean, we have connected currents called the Atlantic Meridional Overturning Circulation, AMOC. Well, basically, you have the North Atlantic Drift that branches off the North Atlantic Gyre, which is a continuation of the Gulf Stream. It cools down, sinks, and there's your AMOC. That's where it starts. What we now call colloquially the conveyor belt. It's a thermohaline density flow. So it distributes ocean's heat, moisture, nutrients, as well as regulate climate and weather. So the climate is continuously changing thanks to what we're doing. The atmosphere is warming thanks to what we're doing. And scientists are concerned that fresh water from melting polar ice sheets could significantly disrupt or collapse AMOC. And what's interesting with this study is they're saying that AMOC is not under threat of collapsing. AMOC is not weakening and hasn't weakened over the last 60 years. Yet, you look at other studies, and other studies measure a slowdown in AMOC. So the question becomes, is weakening what? When the slowdown becomes statistically significant? That needs to be clarified. So a collapse, and the indications are it's not going to collapse, i.e. a total stoppage anytime soon. And I've explained this before in prior videos, most recently my Warming Waters video. However, studies about AMOC's long-term future are uncertain. Instead of predicting the future, a team of scientists from WHOI quantified the past to help inform where this could be going. So a new paper published in Nature Communications, and for my paying supporters on Patreon, Buy Me a Coffee, and my YouTube community, I will be doing a deep dive into this paper, and it's quite wonky. Scientists found that AMOC has not declined in the last 60 years. Authors Nicholas P. Foucault, who is an adjunct scientist in physical oceanography at WHOI, assistant professor at the University of Georgia, Jens Terhaar, affiliated scientist at WHOI, senior scientist, University of Bern, and Linus Voigt, who's a visiting student at WHOI. He's now a scientist at LOCEAN, Sorbonne Université, say the results mean that AMOC is currently more stable than expected. Okay. Our paper says that the Atlantic overturning has not declined yet. So again, decline, slow down. Are they meaning the same thing, or are they having different meanings? And for that matter, weakening. That doesn't say anything about the future, but it doesn't appear the anticipated changes have occurred yet. Their findings contrast with previous work, notably a paper from 2018 cited in their study, which reported that AMOC has declined over the last 70 years. This past work relied on sea surface temperature measurements to understand how AMOC has changed. But I have to highlight this. We've learned that sea surface temperature doesn't work as well as initially thought, said Terhar. Well, duh! How many times have you heard me say that at high latitude, it's salinity that determines density, not temperature? So, surprise, surprise, not really, that sea surface temperature is not a good indicator, not a good index. So to address this uncertainty, Terhar and the team relied on new data from the Coupled Model Intercomparison Project, commonly abbreviated CMIP, climate Earth models produced by the World Climate Research Program. They used 24 different CMIP models and found that the most recently available surface temperature data did not accurately reconstruct AMOC. To go a step further, the researchers looked at a different measure, air-sea heat fluxes, which is the exchange of heat from the ocean to the atmosphere and the atmosphere to the ocean. When AMOC is stronger, more heat is released from the ocean to the atmosphere over the North Atlantic. That's an important statement. We need to highlight it. When AMOC is stronger, more heat is released from the ocean to the atmosphere over the North Atlantic. What happens when the North Atlantic drift moves up into here? It gives off its heat. You have warm salty water, gives off its heat, now becomes warm salty water. And guess what it does? It sinks. That's AMOC. So it's the air. So yes, in some ways it is a measure of sea surface temperature, but you're actually measuring the heat fluxing, the diffusion, the actual movement of heat, not just the temperature itself. You have to measure the heat flux itself to get a handle on it. To reconstruct the AMOC, researchers looked at air-sea heat fluxes, which is the exchange of heat from the ocean to the atmosphere, or the other way around. When AMOC is stronger, more heat's released from the ocean to the atmosphere. So let's see if we can enlarge that. There we go. And in the paper there, they started at 26.5 north latitude, which, as you can see, is about the southern tip of Florida, or pretty much where the Gulf Stream emerges out of the Gulf of Mexico. Not the Gulf of America, the Gulf of Mexico, and swings up the eastern seaboard of North America. And the blue squiggly arrows here indicate heat diffusing to the atmosphere. So it contains ocean heat content. And let's see if I can escape out of that. There we go. And the red arrows are actually indicating the movement, basically meridional heat transport is what they're indicating there. The authors derived this AMOC proxy with the CMIP models, applied it to observational data. The best data for surface heat fluxes over the North Atlantic came from reanalysis products that incorporate direct observations into a model, similar to how weather forecasts are done. Based on the results, AMOC is more stable than we thought. This might mean that AMOC isn't as close to a tipping point as previously suggested. The paper states that air-sea heat flux anomalies in the North Atlantic are tightly linked to the AMOC, and that the decadal average AMOC has not weakened from 1963 to 2017. Decadal average. Since there are many processes that lead to large year-to-year variability in the AMOC, the air-sea heat flux and AMOC are correlated strongest at those timescales as opposed to annual averages. Think of weather. What's happening now, it could be a lot warmer or a lot colder than, say, decadal or centennial averages. That's basically what they're saying. The annual variation is not a good indicator versus looking at the decadal averaging. Now, they're not saying that AMOC is not going to slow. It's almost unanimous it will slow in the future. But whether or not it will collapse is still up to debate. And I outlined what I consider the conditions for a collapse to be present for that to happen. You know, the conditions necessary that have to be present for the collapse to take place. And I do not see those conditions being present at the moment. I did, however, point out that you need to look at what's going on in the Beaufort gyro. So, as with all proxy-based reconstructions, there are limitations and caveats, of course. The authors point out that direct measurements of air-sea heat flux going back in time are sparse. Yeah. And thus the reanalysis contains significant uncertainty. Makes sense. However, despite these limitations, a decline in AMOC over the last 60 years seems very unlikely. So, again, researchers have measured a slowdown in the deep water formation, the chimney formations in the North Atlantic. Now, does the slowdown constitute a decline? Well, how do you define decline? How do you define weakening? Are we basing on that a decline or a slowdown is statistically significantly different than a decadal average? Then we can call it a weakening. Okay, that needs to be clarified. So this is kind of an interesting study here. And as I said, I will be doing a deep dive for my paying supporters. And look for that hopefully in the nearby future. So, like everything else here, stay tuned. Thank you for your time.